Histology of the gut, which includes how the tissues are arranged in the gut. We see in this connection it is the serosa from the outer to inner, serosa, modular layer, then the submucosa and mucosa. These are the four layers of the gut. The four layers of the gut includes the outer serosa, visceral peritoneum. Generally, what we see is among the eucoelomates, the space between the body wall and alimentary canal lined by means of the peritoneum. That's the reason why earlier we have seen a mesentery which is connecting the jejunum and the ileum to the abdominal wall. It is a peritoneum. So a eucoelomate is a member in which the coelom, the space between the body wall and alimentary canal lined by means of peritoneum. So here also the outermost layer is a visceral peritoneum, which indicates that they are the eucoelomates. So outermost visceral peritoneum or serosa. Inside to this is a modular layer. Inside to this is the submucosa and mucosa. So four layers of the gut includes the visceral peritoneum, modular layer, submucosa and mucosa. Visceral peritoneum, which is also named to be the serosa. The serosa is made up of squamous epithelium and connective tissue. It is made up of squamous epithelium and it is with the connective tissue. So serosa is composed of squamous epithelium and connective tissue. So now it is an evident that it's a tissues. Histology. Serosa, visceral peritoneum is made up of the squamous epithelium and the connective tissue. If we go to the details of this serosa or visceral peritoneum is absent in the esophagus. The gut which starts with the mouth and ends with the anus. So we have to observe how far these all the four layers are influencing the gut parts. In the case of esophagus, the serosa or visceral peritoneum is absent. The due reason is esophagus is present outside of the body cavity, as it is outside of the coelom, so it lacks. Coelom is lined by peritoneum. So as it is outside the coelom, so serosa or visceral peritoneum is absent in the esophagus. Next, the part is named to be the modular layer. Muscles are meant for movement. The modular layer which includes the outer longitudinal muscles and inner the circular muscles. Hence it is a modular layer. It includes outer longitudinal and inner circular muscle. This outer and inner circular, longitudinal inner circular muscle layer is named to be the modular layer. And these outer longitudinal inner circular muscle showing variations in the parts. For suppose in the case of the stomach, besides longitudinal and circular, one more layer of the muscles, oblique muscle layers are present. Longitudinal is a vertical, circular is horizontal. What about the another oblique? Neither vertical nor horizontal. So in terms of muscle layer, stomach shows variation. That is, besides the longitudinal outer, inner to the circular layer, inner to the circular muscles, one more oblique muscles are present, which is a variation. Next, digestion process is influenced by even the nervous system also, neurons, nerve plexus. If we go to the details of nerve plexus, there are two types of the nerve plexus, network of the nerves. Nerve plexus are also play vital role in the digestion. There are two types of the nerve plexus associated with the digestive tract. One is named to be the Erbox plexus. Erbox plexus. Plexus in the sense network. Erbox plexus, and another is named to be the Messener's plexus. Messener's plexus. Erbox plexus is also named to be the Myenteric plexus. Now let's see what is this plexus. Plexus in the sense the network. So the Erbox plexus, look at here the diagram where we see in between the longitudinal muscle. This is a longitudinal muscular layer, longitudinal muscular layer, whereas this is the circular muscle layer, circular muscle layer. In between the longitudinal and the circular muscular layers, there present the network of nerve fibers and parasympathetic nerves, the network of the nerve cells and parasympathetic nerves. So as these two are present, network of nerve cells and parasympathetic nerves, the nerve cells and the parasympathetic nerve cells, nerve fibers, what form a network which is named to be the Erbox plexus or Myenteric plexus. Generally this Erbox plexus, which is the combination, the network of the nerve cells and the parasympathetic nerve fibers, is an Erbox plexus which lies between the longitudinal and circular muscle. Diagrammatically we can see here pictorially. This is responsible for peristalsis. Peristalsis. What do you mean by peristalsis? The wave-like movement of the food in the gut is what refers to the peristalsis movement. So mechanical digestion is one of the digestion we see. So the movement of the food is what in a wave-like manner is named to be the peristalsis. This peristalsis is what done by Erbox plexus. So in turn it indicates that the nerve plexus are playing role in the digestion. So Erbox plexus is one. Second one is Messener's plexus, which is also named to be the submucosal plexus. Submucosal plexus. Why? In the sense diagrammatically we came across the one more plexus. This is the Erbox plexus. Erbox plexus. The second one is the submucosal or Messener's. Messener's we are observing after the muscular layer and before the what is called mucosa, which lies in the submucosa. That's what it is, a submucosal plexus. Messener's plexus is a, just now I told you, it is a network. Here the nerve cells and the parasympathetic. Here the Messener's plexus is a combination of nerve cells and sympathetic nerves. Sympathetic. So what we come to know, both sympathetic and parasympathetic are associated with the gut. Thereby they play a role in the digestion process. And digestion is an involuntary action. So the sympathetic and the parasympathetic are involuntary in function. So if we see that in the nerve cells and the sympathetic nerve cells whose combination is a Meissner's plexus, submucosal region it is present, so it is the submucosal plexus, and this is responsible for secretion of the intestinal juice, secretion of intestinal juice, nothing but a saccus entericus. So the two types of the networks is what name it to be the seen along the guide, which is airbox plexus and Meissner's plexus. The airbox plexus is the myenteric plexus, which is the combination of the nerve cells and the parasympathetic nerve fibers, which exhibit the peristalsis movement, and the Meissner's plexus, which is also named to be the submucosal. Why? It is present between the muscular layer and the mucosa, so it is a submucosal plexus. It is the combination of the nerve cells and the sympathetic nerves, which is a Meissner's submucosal, and its function is secretion of saccus entericus. So collectively we learn the nerve plexus also play a role in the digestion. In what way? With the network of nerve cells with the parasympathetic nerve fibers is airbox plexus, which is for peristalsis, and the network of the nerve cells and the sympathetic nerves is a Meissner's plexus or submucosal. One for the peristalsis and one for the intestinal juice. So this is how it helps in the digestion process. That's what the muscular layer, which is outer longitudinal, inner circular, which is all along the length is present, and exhibit what is called with the help of the nerves. It helps in the peristalsis movement of the food, and the muscular layer in the case of the stomach to the intestine. In stomach additionally the oblique muscles are present. Next to the muscular layer it is the submucosa. Below the mucosa, submucosa. Submucosa includes the loose connective tissues. It is made up of loose connective tissue, and it includes the blood vessels and the lymph vessels, lymph capillaries, and to some extent the glands are present. Generally, the submucosa with the loose connective tissue with the lymph capillaries, blood capillaries, and some glands. Some glands, why we are emphasizing? That is in the stomach. Submucosa region, the basis of the glands are present, and the case with the intestine, the Brunner's glands. The duodenal glands are located in the submucosa. That's the reason why it is also with the some glands. Next, submucosa. Inside to the submucosa, it is the mucosa. Mucosa is the innermost layer. Now the thing is why it is named so. Basically, mucosa is nothing but mucus layer. That's what it is. And this mucosa layer is with the consist of epithelium, lamina propria, and the connective tissue. Basically, the innermost layer is the epithelium. This innermost layer is a epithelium which forms the folds in the case of the stomach, which is named to be the rugae. Expansion of the stomach is by rugae. This rugae are forming in the stomach region, that is of mucosa itself. And the epithelium, which is columnar epithelium, it forms the villi, and also it forms the intestinal glands in the intestine, and gastric glands in the case of the stomach. So collectively, mucosa is the inner layer and it is what with the epithelium, lamina propria, and is also with the what is called a connective tissue. The inner layer called the epithelium, which forms the folds, name it to be the rugae in the stomach, which is for the expansion of the stomach, and it is what forms the villi as well as the intestinal glands in the intestine and the gastric glands in the stomach. This is the histology of the gut, and the exceptions we see the muscular layer with the oblique muscles in the stomach, and the submucosa is with the basis of the glands in the stomach. In the stomach region, submucosa is with the basis of the gland, whereas in the intestine, submucosa is with the glands, Brunner glands or duodenal glands, and these are the four layers we see in the case of the gut with the serosa, muscular layer, submucosa, mucosa. Now we move on to the glands. This is what the description with the gut and its histology. Now it is the glands. Glands is to be discussed. The glands are what considered to be. Glands are secretory in function. Glands are of secretory in function. The glands can be of the exocrine and endocrine. Exocrine and endocrine. Digestive system includes the gut and associated glands. The glands are of secretory in function. The exocrine and endocrine in the sense. Exocrine glands are duct glands. By means of the duct they release their secretions. So duct glands. The digestive glands and intestinal glands, salivary glands release their secretions into the buccal cavity, stomach and intestine by means of their ducts. So that is the duct glands. Whereas the endocrine glands are without ducts, so ductless, and they release their secretions into the blood. Through blood it is transported. So now we are going to discuss the exocrine glands. Exocrine glands. Exocrine refers to digestive glands. Digestive glands. And these digestive glands are of internal and external. Internal digestive glands and external digestive glands. Internal and external. Internal digestive glands means inside located, inside present. Internal digestive glands are the gastric glands and the intestinal glands. Intestinal glands. Whereas the external glands are, external glands we see salivary glands, salivary glands, next the liver, pancreas. So let's learn about this. The one that are present outside of the gut. Salivary glands are present in the oral cavity. It's not inside the wall of the gut. The one that are present in the wall of the gut are internal. So internal is in the stomach region. In the mucosa region we find the gastric gland. So is it an internal portion or not? So as it is internal portion, so internal. Gastric, related to the gaster, stomach. So the glands that are present in the stomach, inside the wall of the stomach, so it is internal, which is the gastric gland. Gaster refer to the stomach. So in the gastric glands are present in the stomach region wall, and intestinal glands are present in the wall of the intestinal glands. So it is internal. And the salivary glands, liver and pancreas. Salivary glands present in the glands that are present in the oral region. The glands that are present in the oral region are what? The salivary glands. Generally, salivary glands comes under external exocrine glands. In the case of the human beings, there are the parotid glands, next the submandibular or submaxillary, and the third one is sublingual. Parotid salivary glands. In general, the mammals are with the 4 types of the salivary glands. Infraorbital are present, but in the case of the human beings, the infraorbital are absent. That's the reason why we see 3 pairs of the salivary glands. The 3 pairs of the salivary glands include are parotid, submandibular or submaxillary, and sublingual. Infraorbital is absent. Parotid glands. Look at here. This is the parotid glands. The parotid glands are the largest, and these are present below the pinna or external ear. They are present below the pinna or external ear. Generally, the parotid glands are the largest salivary glands and are present below the pinna by means of the Stenson's duct. Just now we have seen that the digestive glands are exocrine and duct glands. They have a duct. So parotid gland lie below the pinna, and it opens into the upper incisors. They open into the upper teeth by means of the Stenson's duct. Parotid glands or the salivary glands lie below the pinna, and by means of the Stenson's duct they open into the upper region of the stomach. Second upper molars region, they open parotid glands and release their secretions. Next, so Stenson's duct. The second one is submandibular or submaxillary. Submandibular or submaxillary are present at the angles of the jaws. They are located in the angles of the jaw, and by means of their duct, name it to be the Wharton's duct, it opens into the oral cavity by means of the Wharton's duct. Submandibular or submaxillary, these are nothing but the jaws. That's what the maxillary mandible. At the angles of the jaw they are present, hence they got the name. And by means of their duct, which is named to be the Wharton's duct, they open into the oral cavity. Next, sublingual refers to the tongue. Sublingual salivary glands are by means of the duct of Rivenus. They open into the oral cavity. That is central teeth, they open into the what is called a buccal cavity. So this is how we see parotid salivary glands, submandibular, submaxillary and sublingual. By means of their respective duct, they release their secretions. Parotid by Stensons and submandibular, submaxillary by Whartons and sublingual by Ravenous duct. This is how they open into the oral cavity and release the saliva. Salivary glands release the salivary juice. The salivary juice is slightly acidic, which means the salivary juice pH is 6.8. 6.8 is nothing but slightly acidic. And this salivary juice per a day about 1000 to 1500 ml, means 1 to 1.5 liters of the saliva is secreted, which includes the salivary amylase, ptyalin. Ptyalin or salivary amylase is an enzyme. Ptyalin or salivary amylase is an enzyme present in the salivary juice. Besides that, the salts, name it to be the sodium, potassium, or the other salts are also present. Water, mucus is also present. Besides that, the thiocyanate is also present, and an antibacterial enzyme, lysozyme, is also present. Antibacterial. That's the reason why the saliva is of immune purpose itself. Some of the methods in the conventionally olden days, upon the wounds, the saliva is used to be added, which is of antibacterial, so it avoids. This is water. So salivary juice is slightly acidic. Once it is 6.8, so it is slightly acidic itself. The lower the pH value, the higher the acidity. The higher the pH value, it is slightly acidic or alkaline in condition. So the salivary juice is of a slightly acidic with a 6.8 pH value, which is with the salivary amylase. Ptyalin acts upon carbohydrates. So partially carbohydrate digestion takes place in the oral cavity, buccal cavity. It includes the salivary amylase, ptyalin. Besides that, the ions, that is sodium, potassium, and it is with thiocyanate, and it is also with the lysozyme and antibacterial enzyme is also present. For about 1 to 1.5 liters of the saliva is secreted per a day. Next, gastric glands. Gastric glands are the glands present in the stomach. Gastric glands are with according to the regions, they are said. Basically, the gastric juice is highly acidic. Gastric glands are present in the mucosa region, so it comes under the internal exocrine, which includes the cells named to be the axanthic cells and the acidic cells or parietal cells and the neck cells, which is considered to be generally the axanthic cells. The axanthic cells or the acidic cells, one, and the parietal or parietal cells or chief cells, and the neck cells. 3 types of the cells we find. So in this connection, the first one is said to be the chief cells. The chief cells are what are considered to be secreting the inactive enzymes. The gastric juice is of a highly acidic. It's a pH value what to 1 to 1.5. So it is highly acidic. In It is also even considered to be 0.8 to 1.5. So highly acidic juice is none other than the gastric juice. In this, the chief cells are what? Peptic cells secreting the inactive enzymes, name it to be the pepsinogen and the prorenin. Whereas the acidic cells are what? Secreting the HCl and the calcium intrinsic factor. And the next cells are what? The secreting the mucus. So the gastric juice highly acidic with pepsinogen and prorenin as an inactive enzymes, as well as HCl and calcium intrinsic factor, and also the mucus. Even the hormones releasing are also present. Hormones. In the stomach, the gastrin is a hormone released. So collectively, gastric juice is highly acidic with the what is called the chief cells or the chief cells secreting the pepsinogen and prorenin. Pepsinogen is an inactive enzyme which needs to be converted into the active, which is done by means of HCl, hydrochloric acid. The acidic cells secrete the HCl and the calcium intrinsic factor. This HCl, because of the HCl, it is highly acidic, which play a role in the conversion of inactive pepsinogen into active pepsin. That's what it is, an enzyme activator. It kills the bacteria. And the calcium intrinsic factor, which is what responsible for reabsorption, that is absorption of vitamin K, vitamins, vitamin B12. Calcium intrinsic factor is responsible for absorption of vitamin B12, cyanocobalamin, which is done by, so the functional role of the HCl and the calcium intrinsic factor. HCl is an enzyme activator, conversion of pepsinogen inactive into active pepsin, and the prorenin is also an inactive enzyme is present, which is converted into active renin. Basically, infants only with the renin enzyme, which is not seen in the adult. That's what it is, an enzyme activator, kills bacteria. The microbes that enters into the stomach, they are killed by the acidic condition of the HCl. So HCl role, conversion of inactive into active, killing bacteria, providing acidic condition. Proteins are digested at the acidic condition. That's the reason why it is an enzyme activator, and thereby the proteins are digested. Next, calcium intrinsic factor, which is responsible for absorption of vitamin B12, cyanocobalamin. Next, mucus cells are what? Secreting the mucus. Basically, the goblet cells are present, which comes under unicellular glands. That is the goblet cells which secrete the mucus. Mucus play a role in the lubrication of the gut, as well as it is allow the flow of the food from one part to another. This is how we see the gastric glands. Even the gastrin is a hormone secreted in the stomach, which stimulate the secretion of the gastric juice. The pepsinogen, which is inactive, converted into pepsin by HCl. Prorenin is inactive and converted into active renin, which is in the case of the infants. Okay.